Good day once again. My name is Graphics. Today we will be studying trigonometry, an aspect of mathematics, where we'll be analyzing the functions of Of angles, that is, the specific function of angles. Now, we have 6 specific functions of angles, and they are sine, cosine, tangent, cosecant, secant, and cotangent. These are the 6, right? So one thing you need to know is that if we are analyzing them in relation to a right angle triangle, let's assume this is a right angle triangle. Right? And we are taking here, if our angle here is theta, so it means everything here will be what? Theta. So sine theta, cosine theta, tan theta, cosec theta, sec theta, and cotan theta, right, which is cot. Now, if this my angle is facing here, we are going to say this will be my what? My opposite. And this will be the inclined part of the triangle. This is inclined part. Is always giving us what? Our hypotenuse. Right? Then the other third part will give you our adjacent. Now, one thing you need to know is that the opposite sometimes changes to be the adjacent, while the adjacent sometimes becomes the opposite. What did I mean? If I have it this way, let's assume I have it this way. Let me assume this way. I have it this way. Right? And I'm placing my angle here. Let's say this is my beta. Then I will now write sine beta, cosine beta, tangent beta, cosecant beta, secant beta, and cotangent beta, because I'm considering beta, right? So now from here, this will now be my opposite, because the angle is facing my opposite. Then the inclined part is always the hypotenuse. Then this other side will now become the adjacent, right? I will make you understand. So it depends on where the angle is facing. Wherever the angle is facing is my opposite. Now there's something you need to understand. Now let's consider a triangle. Let's assume this is my triangle this way. And this is, let's say here is A, here is B, and here is C, right? Now let's say AB is X and let's say CB is Y and AC is Z. There's something we call our SOH, SOH, right? The SOH here, the S stands for what? Sine. The O here stands for what? Opposite. And the H here stands for what? Hypotenuse. So if I place this angle here, it can be anything. It can be theta, it can be beta, just like I showed you. So let me just, for simplicity's sake and for better understanding, let me say it is what? A. Right? Or let me use the word alpha. Alpha should be better, so to not coincide with other alphabets. If I say sine alpha, sine what? Alpha, because I'm considering alpha. Now my opposite means opposite over what? Hypotenuse. Opposite all over what? Hypotenuse. That's what I did here, right? Now what is my opposite? My opposite is the side the angle I'm considering is facing, and that is what? BC. That will be what? BC all over hypotenuse, and this is the inclined part, which is AC. Right? Now what is BC? BC is what? Y. And what is AC? AC is what? Z. So that is to say, therefore, my sine alpha is equals to what? Y all over what? Z. You should know this. So whenever you're considering sine, you know it is opposite over what? Hypotenuse. Similarly, we know very well that we have what is called CAH, from the word SOH CAH TOA. What is called CAH, right? The C is for what? Cosine, which is cos. The A is for what? Adjacent. And the H is for what? Hypotenuse. So if I'm considering the alpha here, if I'm considering this alpha, so we'll say that my cos alpha is equal to what? Adjacent over hypotenuse. Adjacent all over what? Hypotenuse. Now if you look very well, which will give me what is my adjacent? My adjacent, if this is my opposite that the angle is facing, and the inclined part is my hypotenuse, automatically the third part is what? My adjacent, which is what? AB. So I'll be having AB all over what? All over AC. And AC is this. We were moving up. So from here, my AB is giving us X. As you can see, AB is X. So I'm going to put it there as X. All over AC. AC is Z. AC is what? Z. And that will give me my Z. So therefore we say that cos alpha is equals to what? X over what? Z. We move forward. We have TOA from the word SOH CAH TOA, right? So we're talking about TOA now, and that will be T O A. The T here is from what? Tangent, which is tan. The O here is for opposites, and the A here is for what? Adjacent. right? So since we are considering alpha, so I will say that the tan alpha will be equals to what? Opposite over adjacent. Opposite all over what? Adjacent. Right? Opposite over adjacent. Now, what is the opposite? Like we said earlier, we know our opposite. Opposite should be the side the angle is facing, which is what? BC. So we have BC all over adjacent, which is giving us AC, right? But we have our adjacent. If here is opposite and here is hypotenuse, here is adjacent, and that is what? AB, and that is X. So adjacent that will be AC, AB, and this is going to give me what is BC. BC, if you check the triangle, BC is giving us Y all over AB is giving us what? X. So we say that therefore our tan alpha is equals to what? Y all over X from that triangle. Is that taken? So we've got the three of them. We have cos alpha, tan alpha, and sin alpha. So we move forward. Now we'll go to the inverse of these specific functions of angles, which I've said in my earlier videos, but I'll just do this again. Now we have what is called, we have inverse of functions of angles in trig, right? One of them is said to be what? Secant. And the secant is the same thing. Let's say secant theta. The same thing as saying, since we are considering alpha in our triangle, so let's use alpha. Secant what? Alpha. Since we are considering alpha, let me just put it here. Secant alpha. The same thing as saying sec alpha. We say it is the inverse of, you count 1, 2, 3, and it's the inverse of what? Of course, because the third value is C, so we'll be having 1 over what? Cos alpha, right? And what is cos alpha? If you go back to this, you see that cos alpha is giving us what? X over Z. So we have cos alpha to be giving us what? 1 all over, so cos alpha is what? X over Z. So it's inverse, so this guy will come up to be having Z all over X. So the Z is coming to multiply this way to be Z times 1 all over X, and that will give me Z over X. So therefore we say that our sec alpha is equals to what? Z all over X. This is what you need to understand. Now the next one is cosec alpha. So for cosec alpha, or we'll call it cosecant. let's put that way, cosecant of alpha, which is not saying it is cosec alpha. The same is the inverse of, you count 1, 2, 3. S is for sine, so we have 1 all over what? Sine alpha. And to give me 1 all over, what is sine alpha? If you move up, you discover that sine alpha is giving us what? Y over z. So we'll go down back. So we're having y all over z, which is the same thing is saying z times 1 all over y, and that will give me z over y, because z times 1 is what? Is z. Therefore, we say that my cosec alpha is equals to what? Z all over y, right? And that will give me this. Oh, good. Now, the next thing we'll talk about will be cotan. Well, what is called cotangent alpha, which is in saying cot alpha, and that will be the inverse of 1, 2, 3. T is for tan. That will be 1 all over tan alpha. And what is our tan alpha? If you look, tan alpha is y over x. So I'll be having 1 all over y over x. And this is simply saying x times 1 all over y, and that will give me what? Y x all over what? Y. Are we good? So we'll say that therefore our cot alpha is equals to what? X all over y. So this is what we're having, right? Now, if you divide sine by cos, you say that sine alpha all over what? Cos alpha, right? And we know that our sine alpha is giving us this, y over z, y over z, right? All over cos alpha, and cos alpha is giving us what? X over z. You can see that? X over z, x over z. So if I move forward, I'll say my y over z. If I change the division to multiplication, this z will come up to x and s will come back down. So we're having z all over what? X, because I have changed this division to what? Multiplication. Now if you look at this, z will equate z, and we're going to be left with what? Y all over x. But y over x is equals to what? Y over x is what? Tan alpha. So we'll now say that is equals to what? Tan alpha. So hence, whenever you see tan of any angle, it's going to give us what? Sine alpha over what? Cos alpha. If it's tan theta, it will be sin theta over what? Cos theta. So you should know this. Also, dividing cos by sine, you're going to be having cos alpha all over sine alpha. Is something I'm saying, what is cos alpha here? Cos alpha, like I showed you earlier, is giving us what? X over z. giving us x over z divided by the sine alpha is giving us we have sine alpha to be giving us y over z. If you look at this, we're having y over z, which is this, and this will give me y all over z. So we'll be having y over z divided by x over z, divided by y over z. If I change the division sign, so I'll have x all over z multiplied by, I've changed the multiplication to be having z over y. So this will equate this. So we will now have that, my x all over y. But x over y is equals to this man here. Cot alpha is what? X over y. So it's x all over y give us our cot alpha. So hence, whenever you see cot alpha or cot any angle, it will give you what? Cos alpha all over what? Sine alpha. Is another important relation. So that is to say, in this chapter, what is paramount and very important for you to know is this. So what you need to know is that sec alpha is given to what? 1 over cos alpha. Cosec alpha is giving us 1 over sine alpha. Cot alpha is giving us what? 1 over tan alpha. Sine alpha, as in sine, tan alpha, sorry. Let's say tan alpha. Tan alpha is giving us sine alpha all over what? Cos alpha. And the last but not the least, cot alpha is equals to what? Cos alpha over what? Sine alpha. You see these three things? It is something that you should know if you want to move ahead